We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Hey guys, let's go over 3.15 solving radical, let's just say equations. And this is the intro video for both A and B0. And the directions are going to tell us to solve equations, check for extraneous solutions. Okay, so here's my steps to solve radical equations. Number 1, isolate the radical. Number 2, identify the radical. Sorry, that should say, might be a good time for you to copy, but this is wrong. Identify the index or root. Number 3, use algebraic techniques such as factoring, combining like terms to isolate the variable. Number 4, repeat steps 1 to 3 if needed. And number 5, check your answers to eliminate for any extraneous solutions from the final answer. What's an extraneous solution? You'll first solve for possible solutions. But basically when you check it or it doesn't make the statement true. It makes statement false. It's kind of like, I don't know what to call it, like a fake answer, okay? So let's go ahead and apply these techniques to this example over here. The square root of 2x plus 15 equals x. All right, let me grab orange because that's... The first thing I'm going to do here is isolate the radical. What that means is that there is nothing in front of or behind the radical sign, okay? So step number 1 is completed. Number 2, we need to identify the index or root, and that is right here, which is a 2. Why do I need to do that? So, if I want to now square both sides, the power of 2 and the index and the radical sign go away. And you're just left with its inside, which is the radicand 2x plus 15. And on this side, you just have x squared. Number 3, use algebraic techniques, factoring, combining like terms to isolate the variable. Okay, so to do this step here in green, I'm going to move everything to one side. Now, if I move the x squared to the left side, this would give me a negative x squared, which would try to avoid in quadratics a leading coefficient that's negative. So I'm going to move everything to the right side. So this equals 0, 0, x squared minus 2x minus 15. Here I'm going to see if I can factor. My a is 1. So a times c would be negative 15. My b value, which is negative 2. The two numbers that multiply to be 15 are 5 and 3. One of those has to be negative, so negative 5 times 3 gives me negative 15, and negative 5 plus 3 gives me a negative 2. So that gives me negative 5 and a positive 3. Okay, and now it says repeat basically the steps 1 to 3 if needed. So in red now we already solved it, so we can just do zero product rule. Z0 product rule basically says that each of these equal to 0. Equals 0, equals 0, so I have x minus 5 and x plus 3. You'll notice you don't really need those parentheses here. So I'll just add 5. You'll get x equals 5 and subtract 3, you're going to get x equals -3. Okay, so pay attention. These are my possible solutions. Okay. Okay, now in light blue, change my pen. We need to now check our answers. Eliminate any extraneous solutions from the answer. So basically what I'm going to do is I'm going to take the original problem. Just write it down over here. I'm going to do it twice. Square root of 2x plus 15. Is that equal to? So what we're doing here is we are checking. Check. Is that equal to x? And basically I need to do this twice, so I'm going to press God. Paste. There we go. And maybe I will change this. Can I change this in? Oop, don't want that. Okay, so let's try x equals 5 here. We're going to substitute it in here. And you get everything else the same. 2 times. So now you're just simplifying, so just use your PEMDAS. So we're going to multiply, so I have 2 times 5 is 10, and 10 plus 15 gives me 25. Alright, so 2 times 5 is 10, 10 plus 15 is 25, and the square root of 25 is 5. And the question is that equal to 5? Yes, that is. Okay, so that solution of x equals 5, go ahead and put a check mark. That one works. If I check this one over here, x equals a -3. Let's put it in here for every x value. And let's just see if this will simplify. 2 times -3 plus 15. 2 times -3 is -6, and -6 plus 15 is going to be a 9, and the square root of 9 is 3. And so 3 does not equal -3. So we would say this is our extraneous solution. Therefore, the only one that works is x equals 5. So these are the steps of going through solving a radical equation. We'll see you guys. Alright, A1 tells us to basically solve the equation and check for extraneous solutions. The first thing I want to ask is it isolated? And I just copied down those directions from the intro video, and it is isolated. Because again, there's nothing in front or behind it. Okay, so since it's isolated now, I'm going to identify the index, or the root, which is an invisible number there, which is a 2. Why is that important to us? Because now we can square both sides to get rid of it. This 2 and the 2 with the radical sign are gone, and you're left with 3x equals 36. I'm going to divide by 3 on both sides. 3 divided by 3 is 1. Or we can say cancel equals 1 there, and then x equals 3 goes into 36 12 times. X equals 12. Now, the next thing I need to do is make sure that I check my answer. So you're going to take the original, and we're going to see if this is equal to 6. I'm going to take the x equals 12 here and substitute it in here. So we're going to get 3 times 12, is that equal, square root of that equal to 6, so that is 36. And that equals 6, so 6 equal to 6, that does work. So A1, x equals 12 is an acceptable solution. It's a possible solution, and we check that it works. Okay? Let's try A2. Again, A2, it is isolated already because there's nothing in front or behind it. We can just identify the index, which is a 2, and that tells us to square both sides. Again, this 2 and the 2 and the radical sign cancel, and you're left with just the 4x equals 8 squared, which is 64. Divide by 4 on both sides, and you will get x equals 16. So remember, this is a possible solution. What we're going to do now is we're going to check this possible solution. I take the original problem, square root of over 4x equals the 8. I'm taking x equals 16 and I'm putting it in here. So I'm going to have 4 times 16 equals 8. We're just checking this. And 4 times 16 is 64. Square root of 64 is 8. And 8 is equal to 8. Therefore, this is a solution. Let's try A3 here. Question is it isolated? And it is isolated because there's nothing in front or behind it there in blue. So the next thing is to identify the root, which is a 4. And this 4 tells me to take each side to the 4th power. Now, I like to draw a line down my equal sign to separate the left and the right side. Steps of equality, or some people call these inverses. And the 4 and the 4 plus the radical sign go away, so you're just left with the radicand, which is 5x minus 1. And 2 to the 4th power is not 2 times 4, it is 2 times 2 times 2 times 2, which is 4 times 4 is 16. And then we're just going to solve here. Remember, if you ever need help solving, it's the backwards of PEMDAS. So you're going to do addition and subtraction before you do multiplication. So add 1. 5x equals 17. Divide by 5. You're going to get x equals 17 over 5. So we're going to have to check this. Root 4, 5x minus 1 equals 2. And we're just going to substitute in 17 over 5. So this will become 17 over 5. And I have the 4th root, 5 times, and then minus 1. Okay, with fractions, make 5 a fraction. Put it 5 over 1. And remember, these are factors, or the relationship is multiplication. So here you can do 5 divided by 5 is equal to 1, or we just cross those off. So then I'm left with 17 minus 1. And 17 minus 1 is 16. And that would be 2 times 2 times 2 times 2. So you would have the 4th root of 16 is going to be 2. And so 2 is equal to 2, which means that x equals 17 is a solution for A3. Let's move on to A4. Notice that this one is isolated. There's nothing in front or behind it. Now we're going to identify the index or root, which is a 5th power. So I'm going to now take both sides to the 5th power. The 5 and the 5 with the radical sign cancel, so 3x minus 3 equals 2 to the 5th power, which equals 32. 4 times 4 is 16, and 16 times 2 is 32. Yeah. And add 3. 3x equals 35. We're going to divide it by 3 here. Now 3 cannot go into 35, so we're just going to leave it as an improper 35 over 3. This is a possible solution. Let's go ahead and take the original problem and let's go ahead and check our answer. Fifth root of 3x minus 3 equals 2. And it's a question, right? Is it equal? So here with the equal x sign, I'm going to put in 35 over 3. Minus 3. And here you can just make 3 a fraction by putting it over 1. 3 divided by 3 is 1. So you just have 35 minus 3 to the 5th root. And we're just simplifying here. So I have 35 minus 3 is 32. And 5 identical numbers that multiply to be 32 is 2. So 2 is equal to 2, which means that 35 over 3 is a solution. Remember, you must check your answer. All right, for A5, I'm going to go ahead and copy my little special chart from over here. And this chart kind of just reminds me how to solve. Okay. And why do I need that? Because in this problem here, the question is you have multiplication. So the square root is not isolated. So we need to get rid of that 5 on the right side and the 2 on the left side of the radical sign. So here's multiplication, here's plus. So the question is which one do you do first? Well, we are solving, so we want to do addition and subtraction first. So I'm going to go ahead and subtract 4 from both sides. Why would I subtract 4 from both sides? Darn it, darn. Let's try that again. Subtract 5 from both sides, you will get negative. 1 minus 5 is negative 4. And then you would go ahead and use multiplication and division here. So I'm going to divide both sides by 2. You will get cube root of x equals negative 2. Okay, now the radical sign is isolated. Now we need to get rid of the cube root. So the index there is a 3, so I'm going to take each side to the power of 3. So these will cancel, and you're left with x equals negative 2 times negative 2 times negative 2. And that will give you a negative 8. X equals negative 8. Let's go and check that answer now. Check, check, check. Write the original. And I'm going to put in here negative 8. And 3 identical numbers that multiply to be negative 8. Remember, you can always use your calculator to show you. Okay, cube root is math on the left side. And that would be number 4. Parentheses, negative 8. And you recognize that it's negative 2. So this is really just the same on the right side. So negative 4 plus 5, and this is positive 1. So is 1 equal to 1? That is true. So x equals negative 8 is our solution for A5. Let's move on to A6. Is it isolated? It is not, because I need to get rid of the 4 and the 5. Remember, you are solving, so do addition and subtraction first. So I'm going to subtract 5 here. You're going to get 4 times the root 5 x equals -8. Now we can do the opposite of multiplication, which is division. This will give us the 5th root of -2. And we're going to square, not square, I need to get rid of that 5, so to the 5th power. So this will give us, remember you're canceling also the radical sign, so it's just x equals -32. So let's go ahead and check this. So 4 times the 5th root of x plus 5, is that equal to -3? And let's move this x equals -32 in here. So 4 times the 5th root of -32 plus 5. We kind of already did the opposite of that, so that would be just -2. All of this is going to be equal to -2. So be careful here, it's 4 times, right? Don't think it's 4 minus, 4 times -2 plus 5, so -8 plus 5, and that gives you -3 equals -3, which means it is a solution. That's for A6. Let's move on to A7 up here. Okay, again, our steps are, where did I do those steps? They're way up here. Isolate the radical, identify the index and root, and then use algebraic techniques, and repeat steps, and then check your answer. So let's go down to A7, and you'll recognize that it's not isolated because this is outside the radical, and we kind of need to get rid of that, okay? So let's go ahead and add 7. This would give us 0 here, and this would give me a +2. Okay, now is the radical sign by itself? It is. So now I can identify the index or root. When there's no number, it is a 2. So to undo this, we're going to square both sides. 2 and this 2 and the radical sign are gone, so you're left with 10x minus 1 equals 2 squared, which is 4. And you just solve here. Add 1 to both sides. 10x, this equals 0, and this is a 5. Okay, simple mistake right here. I see students do this all the time. You're going to divide by 10 on both sides, and the answer is not 2. Okay, and let me show you why. 10 divided by 10 is 1. This is 5 times 1, 5 times 2, and your 5s would cancel, so you're just left with 1/2. X equals 1/2. Let's go ahead and check our answer. 10x minus 1 minus 7 equals -5. Let's see if this is the case. Remember, I want to isolate the radical sign, but also do substitution. So this x is equal to 1/2. Okay, don't get scared of fractions now. So I have 10 times 1/2 minus 1 minus 7 equals that -5. And to make 10 a fraction, you put 10 over 1. You can multiply across here. You get 10 over 2, which is 5. Or you can do something like 10 divided by 2 is 5. So 5 minus 1 is 4. Square root of 4 is 2. And 2 minus 7 is negative 5. So is negative 5 equal negative 5? That is true. This means that this is a solution. And let's go ahead and try the last one, A8. Again, this one is not isolated because you have this on negative 11. So we're going to have to move that over. Remember, use the opposite of PEMDAS. So start down here if you're going to solve, which means we're going to add 11 to both sides. (9x plus 3 equals 3). We're going to identify the index, which is a 2, so I'm going to square both sides. What this allows me to do is this 2 and the radical sign go away, so we're left with just the index, 9x plus index. The radicand, the numbers inside the radical, equals 3 squared, which is 9. Subtract 3 from both sides. I'm left with 9x, that's 0, equals 6. And I'm going to divide both sides by 9. These will cancel. Okay, the factors of 6 are 2 and 3. 9 is 3 and 3. You'll notice that my 3's cancel and you're left there with 2/3. 6/9 is the same thing as 2/3. So this is our possible solution. Let's go ahead and check that answer. Check, check. 9x plus 3 minus 11, is that equal to negative 8? And I like to draw a line down the equal sign. Again, in order to simplify or solve for x here, or simplify one side, you can use PEMDAS. So I'm taking the x equals 2/3 and putting it in here. How do you make 9 a fraction? I put it over 1. I'm going to change that to a 3 times 3. Let's do that right there. Okay, that says 3 times 3. And just to the left of the plus sign, it's essentially 9 times 2, which is 18. 18 divided by 3 is 6. Or I can do something like this. So you're left with 6 plus 3 inside minus 11. Something went wrong here. And I changed the number now. Let's see. So square root of 9 is, oh, we're okay, we're okay. Square root of 9 is 3 minus 11 equals negative 8. And that equals our other number over here. So this one works. So there you have it, 8 examples of solving basic radical equations. See you guys.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today.